Hi everybody, this is Chapter 2, Section 1, Solving Linear Equations and Inequalities. These example problems can be found on page 90 to 93 of your Algebra 2 textbook, so if you'd like to follow along in your book, that's perfectly great. So let's get going. All right, today we're going to be solving linear equations, and the main thing that you're going to have to do is isolate the variables on one side of the equation by using properties of equality. So your goal is going to be to have a variable on one side and a number on the other. So your answer is going to look like y equals something. All right, so here's the first example we're going to look at. It says Steve Fawcett set a 24-hour hot air balloon record of 3,186.8 miles on July 1, 2002. Suppose a balloonist has traveled 1,239 miles in 10.5 hours. What speed would the balloonist need to average during the remaining 13.5 hours to tie the record? All right, so what we want to do first is look at this. It says that he's traveled already 1,239 miles already. And then he needs to travel another distance. And his total distance is going to be 3,186.8 miles. Now they didn't tell us what his distance is, so we have to use another piece of information that we know, and we know that distance equals rate times time. So we know if you're traveling 30 miles per hour and you travel 2 hours, that would mean you would travel 60 miles. So we are going to, instead of using distance, we're going to use rate times time. Okay, so we don't know the rate. That's the question. What is the rate? So we'll call that V. But we do know the time left that he has to travel is 13.5. All right, so now we have an equation and we want to solve for V. So our goal is to say V equals something. All right, but our V actually has 1,239 added to it. So we want to get rid of this 1,239. And one way we could do that is subtract 1,239. So that equals 0. But if we do it on the left side, we also do it on the right side. When we subtract that, we get 1,947.8. All right, so now what we have is V times 13.5 equals 1,947.8. So our V is not quite the way we want it. It's still multiplied by 13.5. So we want to get rid of that. And what we can do is divide our 13.5 on both sides, 13.5. So this 13.5 divided by 13.5 is just 1. So that leaves us with a V on one side. And these two, if you did your calculator out, you get 144.3. So our answer is actually the speed he needs to go is 144.3 miles per hour is our answer. All right, let's look at a different problem. All right, our next problem is example 2 on page 91. And there's many different ways you can solve these equations. I'm going to show you two methods. The first method is when we have our problem, 5y minus 7 equals 25. One way we can solve this is divide both sides by 5 first. And when we do that, 5 divided by 5 is just 1. So that leaves us with y minus 7. 25 divided by 5 is 5. Now our y, remember our ultimate goal is y equals something, and our y right now has a 7 subtracted from it. So remember that's plus a negative 7. So what we can do, since that's subtracted, let's just add a positive 7 to that side. And remember, we have to do it to both sides. So negative 7 plus positive 7 is 0. So y plus 0 is just y equals 5 plus 7 is 12. So we have y equals 12. Now we're not quite finished yet. We have to check it. So we say 5 times 12 minus 7 equals 25. 12 minus 7 is 5. times 5 equals 25, and that is true. So we know we got the problem correct. A different way that you could solve that exact same problem is by using the distribution property first. So the problem again, y minus 7 equals 25. So let's distribute. 5 times y is 5y plus a negative 7. So 5 times negative 7 is negative 35 equals 25. And again, remember our goal is to get y equals some number. Well, right now 5y is got negative 35 added to it. So let's get rid of that negative 35 by adding 35 to both sides. If you do it on one side, you have to do it on the other. So negative 35 plus a positive 35 is 0, so that just leaves us 5y is equal to 60. And y then, let's divide both sides by 5 because that y has a 5 connected to it. So 5 divided by 5 is 1, so that's y equals 12. So here we got the exact same answer. You can use either method you like as long as you get the answer correct. And then don't forget to check on either way, but we already checked over here, so we don't need to keep going. Okay, I'd like you to give this a try on your own and see if you can do these two problems on your own. So turn the video off, and then when you finish trying them on your own, turn it back on, and I'll show you how to do them. Okay. So the first one I'm going to do, I'm going to go ahead and divide our 3 and get rid of that first like we did before. So I'm going to divide 3 on both sides. That leaves us with 1, so we just have 2 minus 3p equals, 3 goes into 42 14 times. All right, now I still have this, I have my 3p. Remember, my goal is p equals something, but I've got this 2 over here, and I want to get rid of that 2, so I just have my negative 3p over there. So in order to get rid of my 2, I'm going to subtract 2 from both sides. So 2 minus 2 is 0, so that just leaves us with negative 3p equals 12. All right, and now we don't have our p by itself yet. We have a negative 3 multiplied by it, but we can divide by negative 3. If we do it on the left side, we do it on the right side. So negative 3 over negative 3 is 1, so that leaves us with p equals negative 4. All right, so remember, you always want to go back and check your work before you move on. So let's just fill it in. 3 times 2 minus 3 times negative 4. We want that to equal 42. Okay, so this is a negative 3 times a negative 4 is a positive 12 plus 2 is 14. And we know that 3 times 14 equals 42. So the correct answer is p equals negative 4. So if you distribute it or do it first or did it a little bit different, it's fine as long as you came up with p equals negative 4. All right, so this time I'm going to go ahead and distribute my negative 3 first. So negative 3 times 5 is negative 15. This is plus the opposite. So negative 3 times a negative 4 is a positive 12r equals negative 9. All right, so our goal is to get r to equal something, and right now it's got a negative 15 added to it. So I want to get rid of this negative 15 by adding a positive 15, and that equals 0. If I add positive 15 there, I have to add a positive 15 here. So now I have 12r is equal to 6. Now my r is still not by itself, it's multiplied by 12. So to get rid of that 12, we're going to divide 12. That's going to make that 1. If I divide on the left, I have to divide on the right. So r equals 6 over 12, which can be reduced to 1/2. So r equals 1/2. So, but we're not quite finished. We have to check and make sure. So we have negative 3, 5 plus a negative 4 times 1/2 equals negative 9. So negative 4 times 1/2 is equal to 2. 5 minus 2, and that's 3. All right, and we had a negative 3. So negative 3 times positive 3 is negative 9, and that equals negative 9, which is correct. So our answer is R equals 1/2. Again, if you solved it a different way, that's fine, as long as you came up with the correct answer, R equals 1/2. All right, sometimes your variables are going to be on both sides of the equation, and when we do that, we have to always remember our goal of y equals something. All right, so the first thing we want to do is put our similar terms together. Here we have a 6, a 21, and a 7. So 21 and a 7, those are similar terms. So we're going to have our 6y plus 28 equals, and on this side we have a 4y and a 5y, so that's 9y minus 20. All right, so next thing we need to do is get our y's on the same side. So let's go ahead and subtract 9y from this side and 9y from this side. So 6 plus a negative 9y is a negative 3y plus 28 is equal, 9y minus 9y is 0, so all we have left on this side is a negative 20. So we have all of our y's on one side, but our y's are added. We have a 28 added to it, and we want to get rid of that. So let's subtract 28 from that side and subtract 28 from this side. So that leaves us with negative 3y equals negative 48. All right. Now again, I don't quite have my y by itself. I have a negative 3 multiplied by it, so I'm going to divide both sides by negative 3. And I get y equals positive 16. So let's just check it to make sure. So we have 6y plus, I'm going to go ahead and put those together, 28 equals 9y minus 20. All right, so 6 times 16 is 96 plus 28 equals 124. And 9 times 16 equals 144 minus 20 equals 124. So this is true. 124 is equal to 124. So our answer, y equals 16, is correct. All right, so why don't you try one on your own? Turn the video off for a minute, give it a try. When you finish, turn it back on and I will solve it for you. Okay, so I'm going to distribute because I like doing the distribution. So I have 3w plus, I distribute my 3 to my 7, 21 minus 5w equals w plus 12. All right, my ultimate goal is to have w equals something. So first of all, I'm going to put my like terms together. I have a 3, I called that y, but it's actually w. 3w plus a negative 5w is a negative 2w plus 21 equals w plus 12. All right, so I still don't have all my w's on the same side, so let's subtract a 1w from this. So I had a 1w minus 1w is 0, and if I subtract a 1w there, I have to say minus 1w on this side, so I have a negative 3w plus 21 equals 12. All right, I still don't have, I have my w's all on the same side, but I have a 21 added to it. So let's get rid of that 21 by subtracting minus 21. So that leaves us with negative 3w equals negative 9. All right, so now almost there. I still have to get rid of this negative 3. So I'm going to divide negative 3 by both sides. So negative 3 divided by negative 3 is 1. So that just leaves me with w equals, and negative 9 divided by negative 3 is a positive 3. All right. So now that we've done that, remember it's not finished until we go back and check. So let's go back and check. And the problem says 3, and w is 3, so we're going to say 3 plus 7 minus 5 times 3 equals 3 plus 12. All right, so 3 plus 7 is 10, times 3 is 30, minus 15. 30 minus 15 is 15, and 3 plus 12 is also 15, so that's correct. So our W equals 3 is correct. Again, if you did it a little bit different, that's fine as long as you came up with W equals 3. All right. Now here's a couple of interesting things that sometimes could happen. Let's talk about this first problem. So our goal is always x, in this case, equals something. So let's put our like terms together. We have a 3x and a 4x, so that's 7x plus 5 equals 7x plus 5. All right, so next thing we do is get our x's all together. So let's subtract 7x from this side. If we do 7x on that side, we also have to do it over here. And so now we have, 7x minus 7x is 0, and 0, so we have 5 equals 5. So what that tells us is that x could actually be anything. So let's look at this. Go back up to 7x plus 5 equals 7x plus 5. All right, let's say x is equal to 2. So 7 times 2 plus 5 is equal to 7 times 2 plus 5. All right, and that's 14 plus 5 is 19 equals 19. All right, so if it was 2, it would be true. What if we said x equals 3? 7 times 3 plus 5 equals 7 times 3 plus 5. 21 plus 5 is 26 equals 26. So an equation that is true of all values of the variable, such as x equals x, is called an identity. All right, so this type of problem, when you come up with no x's in the end, it's the identity problem, equation. Okay, let's talk about a different kind. Let's see what happens when we do this. Let's distribute first. So this is going to be 8y plus 56 equals, here I have a 6y and a 2y, 8y minus 8. Okay, so let's get our y's together, because remember, we always want y to equal something. So let's get rid of this 8y and move it. Minus 8y, it happened again. 8y minus 8y is 0 and 0, so we end up with just 56 equals negative 8. And that is not true. 56 is not equal to negative 8. So an equation that has no solution, such as 3 equals 5 or 56 equals negative 8, is a contradiction because there are no values that will make it true. If the equation has no solution, the solution set is the empty set, which is represented as this. Okay, so try some on your own, turn the video off, and then when you're finished, turn it back on, and I will solve the problem, and you can check and make sure you got it right. Okay, here we go. I, again, like to distribute first, so I'm going to say 5 times x is 5x. This is plus a negative. 5 times negative 6 is plus a negative 30. Equals, I've got a 3x and a 2x, 5x minus 18. Okay, our goal is to say x equals something. So let's get our x's all on the same side. We can subtract 5x from both sides. 5x minus 5x is 0. Oh, it's 0 over here too. So we have negative 30 equals negative 18. And that is not true. It never will be true. So this must be a contradiction. Okay. All right, let's try the next one. Let's go ahead and distribute this. 3 times 2 is 6 plus a negative. 3 times negative 3 is a negative 9x equals, okay, let's see, let's distribute this. We have a negative 7x plus a negative 2x. We distribute that. plus a positive 6. So we have, this is a negative 9x plus 6, and over here we have 6 plus negative 9x. So if I want to get rid of get my 9's together, 9x minus, let's see, that'd be a positive 9x. And now, negative 9 plus a positive 9 is 0 and 0, so we have 6 equals 6. And we know that is true, so this one is an identity. All right, let's keep moving. All right, the next type of problems are going to be pretty similar, but this time they are going to be inequalities. So we're going to be using these symbols now instead of just the equal sign. All right, and the graph of an inequality is the solution set. It's going to be the set of answers. You're not just going to have y equals one answer, but you're going to have y equals a lot of answers. And the way that we show that is on a number line. So, and all the points that satisfy that inequality. All right. The properties of equality are true for inequalities with one important difference, and this is really important. So if you want to put your video on pause real quick and write this down. It's something really, really important that you need to make sure you remember. If you multiply or divide both sides by a negative number, you must reverse the inequality symbol. So we're going to do a few problems, so we'll make sure you can learn that, but make sure you reverse the inequality. And this is something that you're going to see on the SAT because they're always wanting to know if you know these little rules. But so if you multiply or divide both sides by a negative number, you must reverse the inequality symbol. Make sure you know that. All right, let's give one a try. This is example 5 on page 93, solving inequalities. The first thing we want to do is we don't really worry about this inequality right now. But what we want to do is have x on one side and a number on the other, just like before. So let's go ahead and move our negative 12x, add that to both sides. So we can get our x's all on one side. So 12x plus a negative 12x is 0 minus 11. And 9 plus a negative 12x is a negative 3x plus 4. All right, so now we have negative 3x plus 4 equals negative 11. All right, so let's go ahead and move our 4 over. So because we want the x to be by itself, and right now we have a positive 4 added, so let's subtract 4 on both sides, minus 4, so that leaves us with negative 3x, 4 minus 4 is 0, equals negative 11 plus negative 4 is a negative 15. All right, but this is not an equal sign, this is actually a less than sign, okay? So we want our x to be by itself, but in order to do that, we're going to have to divide by negative 3 on both sides. Now, let's go back to our rule. If you divide both sides by a negative number, you must reverse the inequality symbol. So we're going to change this. So negative 3 divided by negative 3 is positive 1, so we have 1, but we have to change this to say is greater than positive 5, because negative 15 divided by 3 is positive 5. So our answer is actually x is greater than negative 5. And to show that, we draw a graph. And I'm going to just put a few points in here, 5, 6, 7, 8, and this would be 4 and a 3. Now it says it's greater than. It doesn't say it's equal, it just says it's greater than. So we're going to just circle in. And so any of these numbers except for the actual 5 is going to be true. Okay, so all of these numbers are going to be true. Now, just like before, we still have to check our answers to make sure that we did it right. So let's take the one that we know it's going to be true, anything bigger than 5. Let's choose 6, okay, to see if it's true. So let's fill into our equation 9 times 6 plus 4 is going to be less than 12 times 6 minus 11. All right, so 9 times 6 is 54 plus 4 is 58. And 12 times 6 is 72. Minus 11 is 72 minus 11. I should know that one. 61. So 58 is indeed less than 61. So we know that's true. So we know we did the first part right. But we have two other situations that we want to check for. So the next situation we want to check for is, what about when x equals 5? Now it's not supposed to be true because it says that x is greater than 5, but let's go ahead and check to see what happens when x is actually equal to 5. So 9 times 5 plus 4 is going to be less than 12 times 5 minus 11. 9 times 5 is 45 plus 4 is 49, and 12 times 5 is 60 minus 11 is also 49. And although 49 is equal to 49, 49 is not less than 49. So as we hoped it would not be true, it is not true. All right, and let's try one more situation. Let's try a number less than 5. Let's try 0. It's a nice, easy number. So 9 times 0 plus 4 is supposed to not be, actually, less than 12 times 0 minus 11. So this is going to be 4 is smaller than negative 11, and that is not true, negative 11. So all three situations turned out the way we wanted them to be, so we solved the problem correctly. The problem is x is greater than 5, and so you would need to show both this graph and this answer. All right, so try one on your own. Turn the video off for a second and try it on your own. All right, we're almost at the end of this lesson, so let's just solve this last one. I think it's the last one. All right, so again, we want to have x on one side and something on the other, a number on the other side. So let's start out by getting rid of our 4x and get it to the other side. So 4x plus 1x is actually negative 3x plus 8. And 4 minus 4 is 0, and we have a greater than or equal to 17. All right, so our goal, like we said, is to have x equals something, and right now we have an 8 added to there. So let's subtract 8 from both sides, so that becomes 0. So now we have 3x plus 0 is greater than or equal to 9. All right, now we still haven't quite reached our goal of just x equals, so we need to divide both sides by 3. Now, going back to our rule again, if you multiply or divide both sides by a negative number, you must reverse the inequality symbol. All right, so our inequality symbol right now says greater than or equal to, so we're going to change that to less than or equal to. So negative 3 divided by negative 3 is 1, so that leaves us with x is less than or equal to negative 3. All right, now you're not finished yet. We still have to graph it. So here's our graph. We're going to say this is 0, negative 1, negative 2, negative 3, negative 4, negative 5. It says x is less than negative 3, but it also says equal, so we get to color this in dark. Less than or equal to, and it's anything over here. Anything less than negative 3. So we have to check. So let's choose something less than negative 3 first. Let's try negative 4. So it's in this solution set, so when we fill in with negative 4, we want our answer to be correct, and hopefully it will. So let's say x, which is negative 4 now, plus 8 is going to be greater than or equal to 4 times negative 4 plus 17. So negative 4 plus 8 is actually 4, is greater than or equal to, this is negative 16 plus 17, so that's 1. And yes, 4 is greater than or equal to 1. So we know we got part of it right. Now we need to try, we can go ahead and try 3. Just to, it should be true now. So if we say 3 plus 8 is greater than or equal to 4 times 3 plus 17. 3 plus 8 is 11. And let's see. This should be negative 8, negative 3, sorry. So this is 5 is greater than or equal to negative 12 plus 17, which is also 5, and 5 is indeed equal to 5. So that's true. So let's try one more. Let's try 0. So 0 plus 8. Now we don't want this one to be true because 0 is not in our answer solution set. 4 times 0 plus 17. 0 plus 8 goes there. So 8 is greater than or equal to 17, and that is not true, and that's why it's not in our solution set. Okay, so we have come to the end of our lesson. I hope that you learned a lot, and we'll be doing more of these problems in class. So if you have any questions, be ready to ask them during class on the next time we meet. All right, have a great day. Talk to you soon. Bye.